Hello, this video will go through a few examples of using the product rule to find the derivative of a function. Before we jump in, let's do a quick reminder of what the product rule states. It says if you need the derivative of some function u times v, where u and v are multiplied together, then it will be u times v prime plus u prime times v. So let's do a couple examples. All right. On this one, we want to find the derivative of f of x equals 3x squared minus 4 times 5x minus x cubed. And we want to do it two different ways. We want to first multiply it all out, which is a method we could do using the rules we already had before learning the product rule. And then we want to use the product rule. And then we'll check and make sure that we get the same answer either way. So multiplying it out first, so we'll find f of x. We're just going to FOIL here. So when I FOIL, I'll get 15x cubed minus 3x to the fifth minus 20x plus 4x cubed. And before I differentiate, I'm going to combine my like terms because I see that I have x cubes in two different spots. So let's combine our like terms and we get 19x cubed minus 3x to the fifth minus 20x. So I haven't done any calculus yet. Everything is algebra so far. I've just multiplied this out so I can get a nice polynomial and use my power rule and my constant multiple rule to clean this up and find the derivative. So f prime of x is our derivative. So let's use the power rule. Derivative of 19x cubed is 57x squared minus 3x fifths derivative will be 15x to the fourth. And then minus 20x's derivative will be 20. So there is our derivative. And that is not using the product rule. That is just multiplying this function out first and then taking its derivative. Now let's use the product rule. If I'm going to use the product rule, I need to think about which one is u and which one is v. It doesn't matter which one you assign which. Just take your pick. So I will need to find f prime of x, and remember that's going to be u times v prime plus u prime times v. That is our rule here. But just talk a minute just about kind of the pattern here. Notice this is addition, so these two pieces can be done in either order. It's not necessary that you do this piece and then add this piece. You can do it either way. And notice the pattern is you leave one alone, the derivative of the other guy. Now, since we left u alone the first time, we take its derivative the second time, and we leave v alone the second time. So write one down, take the other guy's derivative, add, switch their roles. So let's take the derivative here. So this will be u is 3x squared minus 4, and v prime will be, that's the derivative of v, so 5 minus 3x squared, plus, and now I switch their roles. I did not take u's derivative the first time, so I do this time. So that will be 6x, and then I leave v alone this time, no derivative, 5x minus x cubed. Okay. And now this is not a way we'd want to leave our answer. We would definitely want to clean this up before we submitted this and multiply out, combine some like terms. So what am I getting? 15x squared minus 9x to the fourth minus 20 plus 12x squared. And then for the next one, we'll have plus 30x squared. Let me move this over a little bit, kind of, so I have some room. Oops, that didn't work. We'll just squeeze it in there. Minus 6x to the fourth. And now let's combine our like terms. I see we have 15, 12 plus 30x squared, so that's 57x squared. I see a minus 9x to the fourth and a minus 6x to the fourth, so that's going to be a minus 15x to the fourth. And then the only constant I have is that negative 20. And so notice in either case, whether I multiply this function out first or if I use the product rule, I'm going to end up with the same derivative. And that should happen always. All of our rules should be consistent with each other. If you can find a derivative in more than one way, you should find the same derivative both times. All right, so let's look at another example. Let's look at f of x equals 4x cubed times sine x. Now, in this one, I don't have the option of multiplying it out. There's nothing to multiply out here, so I have to use the product rule. So I'm going to look at maybe this is u and this is v. So 4x cubed for u, sine x for v. And let's find the derivative. So f prime of x. Remember, the derivative says let's write down our rule again. So it's u times v prime plus u prime times v. So in this case, we'll get u is 4x cubed, and v prime, the derivative of sine x, will be cosine x, plus, now I'll take the derivative of u, that will be 12x squared, and I'll leave v alone, so sine x. And now this is an okay way to leave it. You don't necessarily have to have all those parentheses. You can do 4x cubed cosine x plus 12x squared sine x. That's fine. Just a preview of coming attractions. Later on, we're going to need to simplify things, factor them out to use them. So it may be helpful to start practicing factoring out something common to both terms. I see 4x squared is common to both terms, and I'd be left with x cosine x in the first term plus 3 sine x in the second term if I factor out the common multiples there. All right, either of these is acceptable. And really, actually, that one's fine too. We'll see. This is probably going to be our most standard answer. This one will be helpful later when you need to factor. This one's okay too, just some extra parentheses. All right, let's look at another example. Let's find the derivative of f of x equals 3x cosine x minus 4 sine x. So before I get started, I notice I have a subtraction going on here. So my sum and difference rule says that I can deal with this first piece and then deal with the second piece and deal with them separately. And then when I deal with them separately, I see that this first one will need a product rule because I've got two functions multiplied times each other. This second one, you may see, 4 times sine x, and you may think you'll need the product rule. But don't forget that the 4 is a constant multiple. So that 4 can just hang out and we can deal with it later. So it's just can deal with altogether. So let's find our derivative. So f prime of x. So I'm going to deal with that 3x cosine x first. We'll call this u and this v. So I'll write my u down times the derivative of v. The derivative of cosine is negative sine x plus, and I'm still doing that 3x cosine x. I've got to do the product rule, so I'm going to have two pieces to it. Now I'll find the derivative of u and leave v alone, so that's cosine x. So notice what I've done so far. Switch to eraser. What I've done so far is just this. Okay? I have taken the derivative of 3x cosine x. Now, I need to take the derivative of minus 4 sine x. So that'll be minus 4, and the derivative of sine x is cosine x. So there we go. And this is kind of messy, so let's clean this up. You should always clean up any constants, move them to the front, combine like terms, things like that. So this first term should be written as minus 3x sine x plus 3 cosine x there, minus 4 cosine x. And now I see that I actually can combine some like terms. I have 3 cosine x's, and then I take away 4 cosine x's. So my solution will be negative 3x sine x minus a cosine x. Oops. Yep, that's right. Minus a cosine x. And there's our solution. There is our derivative. All right. Let's look at another example. we want to find the derivative of the square root of x times 4 minus x to the 5th. So here, I see two things multiplied together. We'll call this one u and this one v. Let's find our derivative. So this will be, well, one thing I might want to do might help to remember that square root of x is x to the half. We'll deal with that in just a minute. So when I take my derivative, I have x to the half, just leaving u alone, and I need the derivative of v, which will be negative 5x to the 4th. Okay. Plus, now I take u's derivative. That will be 1/2. We're going to use the power rule, 1/2 x to the negative half. And I will leave v alone this time, so 4 minus x to the 5th. Now we're done with the calculus part, but it's kind of a mess. We need to clean all this up. So let's do some algebra to make this look better. My constant is negative 5. X to the half times x to the 4th. We can think about a 4th as 8 halves if we want to, so that we can combine here. So this is negative 5x to the 9 halves plus, and now I need to distribute that 1/2 x to the negative half. So we'll distribute here, and I'll get, what, 2x to the negative half minus 1/2, and now we can think of that 5 as a 10 halves. So when we distribute, we have that 1/2, and then 5 minus a half will be 9 halves. And I see here I have x to the 9 halves in two different spots, so I need to combine my like terms. So I have negative 5 of them here and negative 1/2 of them here. So that will be negative 11 halves x to the 9 halves plus 2x to the negative half. And there is my derivative. Now, one thing we could have done here, is not always necessary to use the product rule. Sometimes we can multiply out. This one, if we had done a little algebra to start with, we would have had 4 square root of x minus square root x times x to the 5th, which we can clean up. This is 4x to the half, and remember this is x to the half. So this would be x square root of x times x to the 5th is x to the 11 halves. And notice that little bit of algebra at the beginning, multiplying some stuff out. I can now take the derivative, and I get, do the power rule, I get 2x to the negative half minus, and now the power rule again, 11 has x to the 9 halves. And notice we've got the same thing either way. These match. So what you'll see is sometimes you can avoid the product rule if you can multiply out and do a little algebra simplification first, and it makes things a little bit easier. But you're going to have to know the product rule because you can't always avoid it. So make sure you're comfortable with using this product rule.